This is sort of a two-part presentation. I'm going to let Jesse recorded a video, and I'm going to let him sort of open it up and talk about the history and some of the unique aspects of the corona imagery. And then I'll follow up with a very short overview of some of the technical aspects of what we've implemented and how you can get access in the future. So with that, I'll introduce Jesse Casana.
Hey there, my name's Jesse Casana. I'm a professor of archaeology at Dartmouth College up in New Hampshire, USA, and I've worked for many years with Jack Cothren on a project we call the Corona Atlas Project. This effort is dedicated to exploring the archaeological and other applications of this really unique form of historic satellite imagery known by its codename Corona. Corona was the world's very first satellite program that was in operation from 1960 to 1972. And over that time produced an enormous archive of more than 800,000 images covering the entire surface of the Earth at relatively high resolution. These images were collected, of course, for military purposes. And at the time when Corona was first developed, there was actually no mechanism for these cameras that were sent up in space to return digital versions of the imagery. And so instead, the Corona camera had a physical film strip in it. It would fill up one of these steel canisters that Dwight Eisenhower is looking at here. They would be ejected from the satellite and parachute to Earth, where they would be intercepted in midair by a plane with a long hook coming out of the back of it, as you can see going on right here. These images, once they were brought back home to the Pentagon and the CIA, would be carefully analyzed. And this program was an enormous success. In the very first Corona mission, the coverage, which is shown in this map, was more than all of the previous spy plane flights combined. And the imagery was of such high resolution that it enabled US intelligence to look for Soviet bomber bases and other kinds of military or tactical issues that they were interested in researching or documenting. But like most intelligence data, after a few months, and certainly after a couple of years, this imagery was really of little more value, and so it was put into cold storage and pretty much forgotten. Until about 1996, when under a presidential order from Bill Clinton, it was declassified. And since that time, archaeologists have been making use of the imagery for a wide range of purposes. Corona is really a unique resource insofar as it's the only source of high resolution global historical imagery. So there are other forms of historical imagery like aerial photographs from national mapping programs that might provide older imagery but of very small areas. And there are other global forms of historical imagery like SPOT and Landsat going back to the 1970s. But in those cases, the imagery is of such low resolution that you can't actually see archaeological sites and features with much clarity, as in the example of Tel Karkour, a site I used to work at in Syria, shown here in 2-meter Corona versus 10-meter SPOT or 30-meter Landsat. We really need this high resolution to be able to see things in archaeology for the most part. And the fact that this imagery is old is really the other thing that makes it extraordinarily valuable. Of course, today you can get high resolution imagery on your phone of anywhere in the world. But this old imagery that is now more than half a century old actually records a picture of the landscape prior to many of the major changes that we've seen in recent decades. So for example, here in the city of Amman, Jordan, as it appeared in 1967, it was relatively small. However, today that city has grown to enormous proportions. And with that urban expansion, the archaeological landscape that surrounded this ancient city has been pretty much demolished. And that is a process we see many other places in the world. Here, for example, the city of Mosul in northern Iraq, the city of Nineveh, the ancient Assyrian capital, is right next to it, in this case surrounded by this rectilinear city wall. Today, however, much of that region has been covered, including parts of the ancient city, by the expansion of Iraq's second largest city right here. Agricultural intensification is another major problem for the archaeological record because even, for up until the 1960s, in many places in the world, people still used very traditional forms of agriculture. Today, however, they have obliterated that landscape with the imposition of intensified irrigation regimes, deep plowing, and other kinds of strategies that have obscured much of the archaeological record or destroyed many features, as in here in Khuzestan of southwestern Iran. And the third major process that we see, of course, has to do with the construction of dams and reservoirs, which disproportionately impact huge parts of the archaeological record. Here on the upper Euphrates River, for example, in northern Syria, as it appeared in 1968, was filled with thousands of archaeological sites. However, following the construction of the Tap Pit Dam and the subsequent infilling of what's now called Lake Assad, those sites were all flooded and destroyed. Here, a close-up of part of that area in the region of a large archaeological site known as Tel Divi, we can see the mound and many other sites down in the valley bottom, as well as a series of ancient roadways that once connected with the site. However, today, all of that is, of course, underwater or heavily impacted by the agriculture that was made possible by the construction of this reservoir. And on top of all this, because Corona is actually collected in stereo, it's not only possible to view a historic image of these landscapes, but actually to fully reconstruct them in 3 dimensions, as we've done here on that same stretch of the Euphrates River, essentially resurrecting a now flooded and destroyed landscape as it appeared prior to the construction of these dams. So all these examples I've been showing you are basically from the Middle East, where much of my own work has been focused, and where a lot of the research using Corona has to date similarly been focused. But Corona, as this map illustrates, is really nearly global in coverage and provides all kinds of opportunities for similar work elsewhere in the world. As part of our Corona project, we have steadily been increasing our coverage out of the Middle East to now include large parts of elsewhere in the world. We have imagery now available for all parts of China, South and Central Asia, bits and pieces of Africa, Eastern Europe, and scattered coverage across much of the United States, Central and South America too. So I want to stop the sharing of that screen now and just move over to take a quick look at the Corona Atlas itself to see in real time some of the things that we can cover. So when you go to the Corona Atlas, this is what you'll see, a sort of general map of the world that shows in red boxes the areas with coverage. I'm going to zoom into a few parts that I think you guys will be more interested in here in Mali, in Sudan, and in Pakistan. With the first example, this shows the site of the city of Timbuktu as it appeared back in 1966, as you can see here on this imagery. We can zoom in and see many of the ancient features of that city that are still visible really well on this imagery. Like those other cities that we saw in the Middle East, though, the urban expansion there has been extraordinary. And with that growth, many of the surrounding landscape has been destroyed. In this case, I'm using the slider tool that we have on the bottom of the Corona Atlas. Another quick example, this shows an area of the Indus River Valley and south of Mohenjo-daro, where today, we're in the 1960s. In this case, let's see what image this is. This is a 1972 image. Large parts of the archaeological landscape are extant. We can see both sites and canals and other kinds of features. Much of this area, however, has been pretty obliterated today with the intensification of agriculture that's made possible the expansion of irrigation canals into this otherwise arid region. So again, this is probably a rich place for the use of Corona. And one last quick example from Sudan. This is the Upper Nile, and in this case, the Merowe Dam, which is right here, and with the reservoir that's formed behind it. The Corona imagery, of course, reveals the landscape as it existed prior to the construction of that dam, where we can see the Nile River itself, along with all kinds of archaeological sites and features along this very rich part of the world. So there are many, many other potential uses and applications for corona imagery. Hope that you guys will be able to make use of it, and will find this resource as fun and enriching to use as I have. Thanks a lot. And I'd be happy to answer any questions by email. Thanks.
All right, so Jesse gave you a good overview there of some of the value and gave you a quick tour of the atlas itself. But I wanted to talk a little bit about what it takes to get that many images in the atlas and how we've gone about it. The project has taken on sort of two different time frames of development. The first was when we gathered about 800 images of the Fertile Crescent area in the Middle East to develop the original component of the atlas. But the last 1,200 images that have been added to there have been done through a variety of different projects, crowdsourced, if you will. And so one of our big efforts to make this available to everyone was to develop a system that would allow you to download imagery, corona imagery, and to do the same kinds of corrections that we've done to make it available as part of the atlas. And so Jesse talked a moment about, for a bit, about the structure of the sensor system on the corona satellites. It was a stereo imaging view, so you had a forward and aft looking video, like camera system like you had here. You can see the film strips at the top, sort of in bows. Those were the canisters. But in order to achieve the kind of resolution that they did over such a large area, and it is quite a large area for each image, the effect on the ground was that you created sort of this bow tie. And so what happened to that is what happens then to a grid. If you had a grid laying on the ground, that imaging geometry warps the features on the ground. And so in order to be able to overlay the corona imagery on the map at scale across the entire image, we had to apply a panoramic sensor model. And these models are not found in for example, Metashape or Photoscan. So we had to develop our own to do that and apply it. So the first step for anyone who wants to contribute imagery, and there's a large amount of imagery already in the atlas, as Jesse pointed out, but there may not be images over your site. But the first step then would be to go to a USGS, United States Geological Survey site called Earth Explorer, and look under D Class 1 or D Class 2 imagery sources, and you can see the coverage here, and you can zoom in, find the images that you like and identify those, and take a quick preview to make sure there's not cloud cover over your area, and download the images from there. But when the images come to you, they come in sort of four panels, four separate panels. The image you saw, the long strip, is too large to fit on the flatbed scanners that the survey has available. If any scanners in the world, I think nothing will accommodate that long strip. So we have to piece those together using traditional measures like SIFT or SURF and match those and piece that together. Then in order to rectify these to the ground, we need ground control points measured. Once those are measured, we apply the panoramic camera model that gives you that distorted bow tie view that you see there on the lower left. And then finally, we can project those images onto a digital elevation model of the ground to create the orthorectified views that you have. Now, steps 3 and 4 are really to create two different kinds of images, which are both available from the atlas, and we'll talk about that briefly in a moment. So the corona georeferencing crowdsourcing system is something we've called Sunspot. So sunspot.cast.uark.edu. I haven't given you the link here intentionally because the site is under construction or is being modified. It's been available for some time, but it's being modified to accommodate KH7 and KH9, and so it's not functioning just yet. So we're not ready to give it to you to give access just yet. But Sunspot gives you the ability to implement all of those steps. So the first step here is to upload and process the images, and then sort of define the fiducials or the image boundary on the film frame, and then georeference those using a Google backdrop. imagery, and then be able to monitor the addition of those images and then push them out to the atlas. And so this is one, this is the measuring interface that we have on Sunspot. So you have the Google backdrop on the left and the Corona image on the right. And you can see in red there, those are previously measured ground control points. Those are stored in the system. And the new ones that are added, you can see in green there. So this is an interactive system that allows you to go through and measure and remeasure points as you like. Once that's done, you have a list, and we have about we have individual users in the system, so it does require registration. But we have over 2,500 images, I think, now that are in Sunspot and have been corrected to some degree or another. What comes out of that process then are two kinds of images. One is a geotiff image that has been orthorectified against SRTM, the shuttle radar topography mission data from that area. But in order to orthorectify it, we really need a 3D to 2D projection model, and that's what's available in the NITF version. So the advantage of downloading that version from the Atlas is that you can apply your own DEM or improve the registration process in an application like QGIS or ArcGIS or Envy or whatever application you might have. And there are, besides QGIS, there are a couple of other open source tools to do that. So, and that once that's done and it satisfactorily passes the QA/QC process, quality assessment and quality control process, it can be pushed to the Atlas to be available for everyone else. I will note that each, when you order an image from USGS, if the film has not been scanned, it will cost, I think, a $50, it's either a $30 or a $50 fee now. But if it has been already scanned and delivered to someone, it's available free for FTP download. So with that, we wanted to keep it short at the end of the workshop here, but feel free to contact any of us. Jesse and I were the PIs on most of the projects and sort of led it, but Chris Angel at CAST and in the USA is the lead developer on this, and he is the one who can answer a lot of specific questions about the mechanics of the site. And of course, we want to thank our funding, and you'll note that the funding has largely expired. We've been managing the site now for almost 4 years and are continually getting small sources of funding to keep it running and intend to do so for as long as possible. So thanks again for the time, and I'll turn it back over to Stefania.